Bon, ce que je veux dire par là, c'est que quand on lance l'application, donc on n'a même pas le temps de voir le logo, quoi. Donc là, s'il faut au moins se ralentir, c'est pas quoi, 3 secondes au moins, pour l'on voit le logo bien qui apparaît bien avec le slogan, donc le logo, quoi. Hein? Je pense que c'est important. Et ensuite, voilà, ça part sur la carte.
Hello everyone, good evening. Can you hear me?
Yes.
Okay. So after 2 or 3 minutes, we will start our today's session. So our online training on Google Earth Engine for remote sensing analysis for beginners 7 batch. This registration is open, so anyone can join this our new training session 7 batch. This class will be held the 16, 17 and 18 December, and if you are interested, then you can contact with this WhatsApp number, as well as you can also contact with me this email ID. Okay, so and the first 5 registered people can get the 50% promotion. Okay, so if you are interested and if you also get the 50% promotion, then you can, as soon as possible, you can booking your seat. Okay, so thank you.
Sir, I have a doubt, sir.
Okay.
Sir, while importing the shape files, it keeps on loading and it is not getting like loaded. It's before importing, it should load, right, sir? It's not even loading, sir. Is it because of any insufficient files, sir? Um,
Okay, you can share your screen. I will try to solve that.
okay, okay,
Okay, I will give you permission.
okay, sir. Sir, is it visible, sir?
Yeah. I can see it.
This one's 1 point. It is always less than 2%, sir. It is not proceeding further, sir.
So
These are the, sir. Like is my entire screen share for me?
this is the shape file. Yeah.
Yes, sir.
So you can try it again for uploading the shape file.
Okay, sir. Uh,
Okay, it will be loading.
yes, sir. I
You must be selected the 4 files .ssx, .ssp, .prj
oh,
and .dbf.
okay, sir.
After this,
Like I said, it is showing 100%, but still it is not shown here, sir.
Okay, you can select the 4 files only.
Okay, sir. CPG, DBF, PRG, and SH shape.
ssc.ssx.prg and dbf, these 4 files. .ssx
Okay, sir.
and dbf, not cpg, not cpg.
Okay, okay, sir. Okay.
dbf, yeah.
Okay.
It will be take some time. After it will be loading, then it will be continue the 100%. Then you can see your tick marks and it not completed yet. You can see the below.
Yes, sir. It's not completed, sir. It is highlighted in red color, sir. That's why, but it's showing 100%.
So if you have the can you open this the shapefile and the other software just ArcMera of QGIS, and if you have shapefile has the some problem, just the georeference problem or other problem, then the shapefile is not working here.
Okay, sir.
Okay, so you can check it, then you can also try it, and if you don't know
Okay.
this, then you can also knock me. I will try to solve this problem. Okay.
Okay, okay, sir. I will check it out.
Okay. Now stopping your sharing.
Okay, sir.
Can you see my screen?
Yes, sir.
Recording in progress.
Okay. So hi and welcome to the second day's beginners course on Google Earth Engine, and I am Mijan and I will be tutor for this course. So today our course content will be, first of all we discuss about the filtering and visualizing the satellite images in Google Earth Engine. In this part basically we will try to show you how you can easily filter the Landsat as well as also Sentinel-2 imagery, how we can filter and visualize the satellite images, and after this how we can easily export these satellite images and use these satellite images the other software, just ArcMap or QGIS software. Okay, then how to analyze the GPM, it means the global precipitation measurement 3-hour dataset using Google Earth Engine. So basically in this case I will try to randomly select a dataset. This is the global precipitation measurement 3-hour dataset. I select this dataset and I want to make the time series chart. Okay, you can make the any time series chart of any dataset or any image collection. This is the same procedure you can apply. Okay, then we also show the one MODIS and Landsat data for the calculating the NDWI. Then we also talk about the how to export the TIFF images and how to export the any shape file from the Google Earth Engine. Okay, we also discuss about this part. So we will start this after we completing our yesterday's one topic. So this topic is the reprojected scale value. Okay, I will finish that, then I will back to our this today's session. Okay, so you can see here today we will complete it the NDVI for the MODIS, for MODIS data, MODIS NDVI data. So but this data set is not the reprojected. Okay, if you want to check it, then you can get the value this value is not the match with your NDVI. We already know that NDVI value is between -1 to +1, okay, this portion, but you can see here this value is the larger, because if you want to see the image collection bands, you can see here the min and max pixel value between this range, okay. So now we want to reproject it this scale, okay, and get the correct value of the NDVI -1 to +1. So now we will try to show you how you can easily reproject your scale value and get the right value, NDVI right value, okay. So for this you need to make a function, and after this you can see here there is a scale, you can see this is the scale value, okay. Just we want to multiply this scale value with the whole collection, then we can get the reprojected scale value, okay. So this scale value is already here. So now we need to make a function. After this we just multiply this value, scale value 0.001 with the whole collection, then we can get the reprojected, and we can get the expected result from -1 to +1, okay. So now we will reproject it using the scale factor. So first of all we need to make a function. We already discussed about the function yesterday, how you can define the function. So when you define the function, you can define the function with the two way. If you want, you can use the var keyword, or if you want, you can also don't need to use the var keyword. First of all, I take a variable, I take the var keyword, and I can give the variable name is scaled NDVI, okay. I can give this variable name, and then I simply use a function, okay, and I apply this function. This you can see, I will try to show you that. I simply use the print and see how many images will be available between this time frame. I simply use the size function, okay. I simply use here, you can see there are total 130 images will be available, and this image scale is not reprojected, okay. So now I want to reproject it, so that's why I simply call this variable, okay. I simply call this variable. So I simply call this variable in here, I simply call this variable, I simply copy this variable name and paste here, okay. And after this I use a function, this function called the map function. This map function will be add our whole function, okay. I simply use the map function. This map function add our function, this 138 imagery, and it will be reprojected, okay. So that's why this map add your function the whole collection, okay. Now I define my function, so I can simply use the function keyword, and then I make a element name, element as a variable. I can give this element is the image or img. I simply put the image, and after this I use the curly bracket, and I can get my argument what I need. I want to need a image, which image multiply with this scale factor, and here I define this image element variable name is the img. So I simply use here the return function. I need to return this image will be multiply, it will be multiply with our scale factor. Our scale factor is 0.0001, okay. So just I can simply use a variable scaled NDVI, then I call my filter NDVI, because it's here included the 138 imagery of Mortis NDVI between this time frame, but this image is not the scaled or reprojected of scale, okay. So that's why I simply call the filter NDVI, and then I use here the map function, because I make a function, you can see I make a function, and this function multiply the 0.001 with the whole collection, okay. So it will, this map function is working for the connecting this function with the whole collection, okay. So then I simply make a function, I then make the element name, this is the image, and I return this image, it will be multiply with 0.001. okay. So any question in this here, any doubt?
Sir, that what does that map function exactly do,
Map
sir?
function is connecting the whole function with your collection. You can see I make a function here, okay, this part function image, I can return this image and multiply, and this function will be connecting with our whole collection. Our whole collection is the filter and DVI.
Okay, sir.
Here included the 138 imagery. So now it will be connecting and working this function. It will be multiply the 138 imagery with the 0.001 scale factor. Okay. So now
Okay.
I want to define here the copy properties, and I define the image. It will be reprojected the scale value between the start time start and in date. Okay. So I simply use here the copy properties. And define the image. This image, it will be system time start as well as system time int. Okay, so it means I can simply use here, you can see my system has included this time. I can simply define this reprojected value, it will be -1 to +1 between this time, which time I defined it. This is my start time, this is my end time. So I define system time start and system time end. Okay, so now you can see here this function, this totally reprojected. Okay, so now I want to add, simply add. So I simply copy this variable and I can get the mean result. I simply paste here. So now if this the filter and DVI, I can get the 138 images, and after this I just reprojected, just multiply this value. Okay, I can get the 138 imagery, but this now this images is reprojected, and this value is between -1 to +1. Okay, so now I can get from here the median result. So I simply copy this variable name and paste here. Okay, and everything is okay. So now I simply click to the run. So now we can see totally a white map, because we expected our value will be -1 to +1, but in this time you can see here I defined the mean and max pixel value 0 and 8000. So that's why I need to simply change here. It will be mean pixel value -1 and max pixel value will be +1. So I simply click to the run. Okay, so now if you want to check this result from the inspector tab, I simply click on the map. You can see this result is 0.56, and this result is the between the -1 to +1. Okay, so this is the way you can make a function, just multiply this 0.01 and reprojected it. Okay, so now if you want, you can, when you use the land surface monitoring, the different types of the data, this data will be Kelvin. So now you want to convert this degree Celsius, you can just using the same way, just you can use the equation. What's the equation to convert the Kelvin to degree Celsius or degree Celsius to Kelvin? Okay, just you can put the equation and you can get this result. Okay, so any question or any doubt?
Sir, you said reprojection. Reprojection means like projecting into some datum, right? So like WGS84 or Everest datum. But we don't do any such activities here, right, sir? We are just multiplying
So
it, and we are just.
it's the reprojected scale value. You can see here, this is one modis NDVI, and this value will be indicating the mean and max pixel value between -2000 to 10,000. Okay, max result, and it has a scale value. Okay, so now I just multiply my image collection with this value and I can get the reprojected value. Okay.
Okay. Okay.
Okay. So now it
So
will,
then if we set that value should, the minimum should be like 0 and maximum should be 2, even that is possible, sir.
yeah, you can also just you can put here, then you can get this between this mean pixel value or max pixel value between this result. Suppose I can simply use the 2.
Okay.
Okay, you can see this. Actually this it's defined your the mean pixel value and max pixel value. Now we can see this result here.
Okay, sir.
I have a simple question.
Yeah.
Sir, my question is before reprojected and after reprojected, what's the difference between two images?
So when you first of all this image, the modis image, and they already provided this image is the whole collection of the whole world. Okay, you can see here this is this result defined from the this mean and max pixel value will be already defined this data collection. But we know that NTPI result or any index result it between the -1 to +1. Okay, so that's why we need to reprojected this scale factor or scale value, so that they already provided the scale value. Just I can multiply this scale value with my image collection, then I can get my reprojected scale value between -1 to +1.
Okay, I got it.
Okay. So
yes, I got it.
Now we will start our today's session. So first of all, filtering and visualizing the satellite images in Google Earth Engine. So it's one of the most fundamental part of Google Earth Engine is selecting and filtering the image you need and display these images on the map. Google has already selected a wide variety of public dataset that you can easily use the dataset. We already know the dataset link. You can simply go to this Google Earth Engine dataset website and you can get all of this data. Okay, or if you want you can also search them in the search bar of the code editor. Okay, then you can get this data. So suppose when you filtering any satellite imagery, then you need to know some factor. First factor you need to the, suppose you want to make a specific region, you want to need for a satellite imagery for a specific region, it will be Dhaka city or other region what you need. Okay, then you also need to know some image properties. Okay, if you want to know this image, you want a image which image it will be not more than cloud percent. Okay, more than 1% cloud cover. This is the image properties. So this is the another factor, and you need a specific time frame of the image. It will be 2070 or another year. Okay, so just when you filtering any satellite imagery, if this is our main factor, 3 factor, select your specific region, then you can select your specific image properties. It can be cloud cover or other properties what you need, you can select this, then you can select your specific time frame of the year. Okay, or a specific date what you need. So now I simply go to my code editor and practically try to show you all of these things. So I open a new code editor. I simply search in the top of the code editor from the search bar. I simply search here Landsat 8 top of atmospheric. So I simply use here this collection. So here you can see all of the details about this collection. You can see dataset availability date, dataset provider, collection snippet. You can see that different types of the band, description, wavelength, resolution. Okay, image properties. Okay, you can see different type of image properties. You can simply click to the import. This image collection will be imported in your code editor. Here the default variable name is image collection. If you want, you can change it or not, it's totally dependent on you. I simply change it and gap this name is the L8. Okay, so now I want to check how many satellite imagery will be available for a time frame. You can see this satellite imagery will be provided start from the 2013 and present date will be present here. So I want to check it how many images will be available. So I simply use the print function, and after this I simply call my variable name, and then I simply use here the size function. I can simply click to the run. So now it will be computing how many satellite imagery will be available. So you can see here there is the totally the large collection, more than 1 million of satellite imagery will be available for the whole world. Okay, so now we have to filter it somehow to figure out what function we can use. So mainly we can filter these images for a specific region, a specific time frame, or a specific image properties. Okay, so first of all we select our specific region. Suppose I want to make I need a satellite imagery of Landsat 8 for Dhaka city, and I want to need a satellite imagery which will not be more than 1% cloud cover, and I also need a satellite imagery for year of 2017. So I can make this factor one by one, and I can filter this whole collection, okay, one by one. So first of all I simply take a variable, and I simply grab a variable. You can use the any variable name. I simply use the variable name is the filter region. You can use any variable name. I simply use the filter region. Okay, and I also need to import my shapefile. I already know that how you can import your shapefile. I simply import my shapefile from here. I simply click to here, it will be imported in my code editor, and I can change this name. This name is the region. I can change this name region. Okay, so first of all I take a variable filter region for filter my specific region of interest. Okay, so now you can see here this is my large collection L8. It included the 1 million satellite images, more than 1 million. So now I want to check how many satellite imagery only for my region of interest Dhaka city. Okay, so I simply use here the L8. I call my large collection, then I use a function. This function name is the filter bounds. So filter bounds, the filter bounds let you filter images that fall within a certain region. Okay, so here you can see this is the description of this filter bounds. So here you can see this argument is the geometry. It can be point or it can be your region of interest. So here I already uploaded a shapefile. This shapefile is the variable name is the region. I simply put here the region. It means that this L8 or Landsat satellite imagery intersecting with my region of interest. Okay, for Dhaka city. Okay, so now I want to check how many satellite imagery will be available for my Dhaka city. I simply use the filter region, this function, and then I simply use here the size function. Okay, and click to the run. So now it will be computing. You can see for the Dhaka city there are the available 307 satellite imagery between this time frame. This time frame is that 2013 to 2021 November. Okay, so now you can see here I filter these images for my specific region, and these images has the included the 1%, 2%, 5% cloud cover or more than cloud cover, but I need the only for those images which image will not be more than 1% cloud cover. Okay, so now I want to filter the image properties, okay, or image metadata. So I want to make a variable. I can take a variable. This variable name is, I can give this filter metadata. You can use the any variable name. And now you can see this 307 image, it will be intersecting with my region of interest, and this image has the 1%, 2% or 5% or any cloud cover. Okay, but I want to only for those images which image will not be more than 1% cloud cover. I just simply call this variable, and then I simply use a function. This function name is filter metadata. Okay, and I want to check what's the argument of this function. You can see first argument is the name, then operator, then value. So name is the image properties. You can see here our information sheet. You can see there are the different types of image properties. Okay, I want to work with this cloud cover. I need these images which image will not be more than 1% cloud cover. I simply copy this cloud cover image properties, and then I simply use here, but it is the string. I simply use the single quote or double quote. Then operator, I want to this cloud cover less than 1%. So I simply use a operator. This operator is the less than, then my value is that 1. Okay, so now I want to check how many images will be available for my Dhaka city which cloud cover will be less than 1%. I simply use the print function, and then I simply copy the filter metadata and paste here, and after that I simply use the size function, and I simply click to the run. So now we can see how many images will be available. You can see 45 satellite imagery will be available with cloud cover less than 1%. Okay, so if you want to check, I want to need for the 5%, I simply click to 5 and click to how many images will be available. You can see 80 imagery will be available. Okay, so this is the another factor for the image properties. So now this 45 satellite imagery, this stay in the Dhaka, this intersecting with the Dhaka city, as well as this cloud cover is the less than 1%, and I also need the image for the specific time frame. Suppose I need the image for the year of 2020 or 70, what I need. So I simply take the another variable, and I can give this variable name is filter date. Okay, and then you can see this 45 imagery will be stored this variable filter metadata. I simply copy the filter metadata, and then I use here the filter date function. Okay, and then you can see the argument start date and end date. I want to need for the year of 2017. I simply use the word 2017 1st January, as well as on end date it will be 2017 December 31. Okay, so now I want to check how many images will be available for my specific time year. Okay, I simply use the print function, and then I simply call the filter date function variable, and then I simply use here the size function, and I want to check how many images will be available. So you can see only 6 satellite imagery will be available between this year 2017, and if you want to check these 6 images will be not capturing at the same time of the year. I want to check when the image will be taken for the different 6 images will be taken for the different time. I want to check it. So just I simply use here the filter date function, and then I simply click to the run. You can see all of this information image collection. You can see there the total the 6 elements and 12 bands will be available. I simply click to here. You can get the feature. Here you can see first image 0, it indicating the first image, and you can see this image will be taken or capturing for the year of 2017 February 18. Okay, you can see the second image, all of this date will be available. Suppose you want to need a specific time or a specific date of the image. Suppose I want to need for this image for this date, so I can simply copy this image ID. Okay, I simply copy this image ID. This image is for the February 18 year of 2017. I simply copy the image ID and then I take a variable. Suppose I can take the variable, this variable name, I can give this variable name is image. You can use any variable name, and then I take a function ee.image, and then I simply paste here my ID of this image ID. Okay, sorry, it will be not copied, so I again copy from here. This is my image ID. Okay, image ID I copied from here. It is the string. You must use here the single quote or double quote. And now I want to show this image result in my map interactive view. I just simply put here the map dot add layer function, and after this I simply use the object name is the image. Okay, I click to the run. A new layer will be added, but it not be focusing where center of the shape file. I simply use here the map dot center object, then my region, and I also put here the zoom level is the 10. I simply click to the run. You can see it intersecting with our region, but it's not clipping with our shapefile because we don't need to use the clip function. I just simply use the clip function and then simply use here the region. This is my shapefile. Okay, I simply use this and click to the run. So now you can see this image is the